So the if else condition is used when we actually want to execute a certain piece of code based on a certain condition. So if a certain condition is true, we'll execute that. Otherwise, we'll not execute that. And if provided, we may execute some other piece of code. So there can be any number of levels of if and else. So and we can even put one if else inside another if or else, or we can code them any way we will. Whereas switch condition is used when we actually want to perform multiple conditions, multiple pieces of code, especially when we have to check the equality condition. When a certain expression has to be equal to a certain value, we want to execute a certain piece of code, and the same way if there are so many values it has to be equal to, and then many different pieces of code has to be executed, we use switch case. Okay, so the switch case syntax will be something like this. Uh, in the switch, in we give an expression, and then in the case value we have to give the actual constant value that we want to compare that expression with. So whichever case gets evaluated, that gets whichever case gets case is equal to the expression given in that switch parenthesis, that will be executed. And if there is a break statement, the rest of the cases will be skipped. Otherwise, the rest of the cases will be executed as if whether the case value is equal or not. And default is used when we want to execute the like else condition, like none of the expression given is matching to none of these values, then execute the default statement. Okay, so this is like a last resort when nothing else is matching. So that is how switch case works. So now, so far I've also showed you that I also showed you how to use those things. So I'm not going to give you the demonstration again now on this. So let's go to a topic called loops. Okay. So far we have seen one condition and then one conditional code. That's it, and it gets executed only once, nothing more. But what if we have to code something? If you had actually done the program of adding all the values in an array without using loop, then you would actually have understood the importance of loops even better. But never mind. So we can even understand it here also. So how the loops work is they have a condition, and then they execute certain conditional code, and then they test that condition again, and if that condition is still true they execute the conditional code, and it repeats that process until the conditional condition becomes false. When it becomes false, the program execution comes out of that loop. Because that is forming a loop, this is called as a loop. So there are different kinds of loops in Java. One is while, another one is do while, and another one is for. So while loop is the simplest loop in Java language. If you are aware of any C or some other programming language, syntax and all will be exactly same. There won't be any difference at all. So let's say we want to find out sum of all the elements in an array. So how do we go about it? First we initialize array, like we put values in the array, and then we set the value of sum to 0, and then we'll check whether we visited all elements or not. If we did not visit all elements, we will add that element to sum, and then revisit the next element and check if we have visited all. And if that condition is true, we will be going ahead in a loop until we finished, until we matched with all until we have visited all the elements in the array. So this is a typical way of how a loop works, not just a while loop. This is how a while loop works. So sorry, any loop works. So there will be a condition. Until that condition is satisfied, we will be in the loop of in that loop. So once that condition is true, we'll come out of the loop. The while loop syntax is while, Boolean expression, and the loop body. Loop body can be a single statement or even a null statement, or a multiple statements exclusive. braces. So it tests the condition that is provided in the parenthesis. If it is true, it executes the loop body, and if not, it exits the loop. If it is true, and then it executes the loop body again and checks the expression again. Execute to check expression. So as long as it is true, it gets executed. So now let us see a small program. Okay. See, let us say we have an array. I showed you how to use an array in the last time, right? So now, how do you actually put elements in an array? We can put that. We can access the individual elements of an array by using indexes, like from starting from zero. If we say one, all the elements in that array will be the first element in that array will be one, whereas the rest of them will be zeros. That is the default value of an integer in Java. So if we say array of 1 equals to some 23, so the 10th element will be 23. So likewise, we have to, if we want to put values in an array, we have to continue until whatever the last index is. So as I said, the array index starts from 0. Okay. So the array index, because array index is starting from 0, what happens is the array is, this is size of an array. So how many elements are there going to be in an array? So when, as you said, 10, there will be 10 elements. So because we are starting from 0, the maximum index will be, can any one of you guess? Either Srinivas or Mani.
Nine.
So that's true. So Mani, you understood how it becomes 9, right?
Yeah, yeah, I understood. I thought of saying by the time he was told it. Yeah, it starts
Okay.
from 0 to 2, right? Yeah, arrow
Okay.
of 10. Yeah, I already seen.
If we don't have something called as loop, a program, we have to write something like this. Uh, so imagine that we have kept the 10 elements array, okay? Because this is 10, it doesn't look like such a big pain in the ass. But imagine there are 1,000 elements in this. So if you have to write a code like this, it becomes so daunting that you really don't want to write any program at all. So that is why we were given something called as loops. So now imagine we want to put some random number into this array. Okay. So how do we put random numbers? So the random numbers can be generated by using this random r equals to new random. Now when we say r dot next int, that gets a value that generates a random number and puts it in this array. And the same way, if we can copy paste that same thing. So this random is like a helper utility. So it helps us generate random numbers. So random numbers means when you execute that, it may generate something, and when you execute it again, it may generate something else. Okay, remember may. It's not guaranteed that it will be the same way. So now we want to print these numbers. So how do we do that? Array of 0. So now of this and of this, what is the variable? Can anyone tell what is changing in these statements?
Index.
Absolutely. So because the rest of the code is same except for this index, what we can actually do is we can use something like this int, let's call the name variable name index only, or we can even call it as index I equals to 0. Now let's put I plus plus. Okay, and let's put that same I plus plus all the time. Now what happens is, because this is a positive evaluation, so this will become array of 0. If we had kept plus plus I, this would become array of 1, because increment will be done first, then the value will be placed in this expression. So this is array of 0, and then we are printing array of 0 and then incrementing I by 1, and then we have incremented. So now if you see, the entire code has become a constant, right? There is no change in the program at all in each of these lines. So we don't really have to repeat in these cases. When we can replace a certain variable and the code becomes exactly same. Okay, in place of some numbers, if we replace some a variable, the code becomes exactly same, then we can use loops, not only while, any loop. Okay, so now because we are now discussing about while loops, let's see how to use while loop. So now int I equals to 0 is something that we would always use. Okay, we have to use for array also, not I, any variable. So let's call it j because we have already used a here. So while, let us say, where do we stop? When we reach the last element, right? When j is less than or equals to 9. So this condition will be true as long as I is less than or equal to 9. Okay. So now what we want to do is we will simply want to put it like this. Okay. Or even, because to make it more clear for beginners, we can put it like this. So now what happened over here is this. This condition will be tested first. So j equals to less than 9. So obviously what happens? This gets executed. I'm sorry, this is not a, this should be j. Because in this loop, the variable is j, not I. Okay, so now what is it we are doing? We are checking whether the j value is less than or equal to 9. J value is 0, which is less than 9, so this gets executed. So because value in j there is 0, the value 0 will be replaced placed in place of j. So this becomes 0 when this is getting executed, and then j will be incremented, and that becomes 1. So while 1 is less than or equal to 9, it prints array 1, and then 2 is less than or equal to 9 is also true, so it prints array of 2. So that way this repeats the same execution. So now let's execute the program and see what happens. Now if you see, it has printed various different numbers. Okay, why we got such a different numbers? Because as I said, this generates a random number. There is no guarantee
Random.
as to what will be the number, so it generated all these numbers. So we cannot actually, we cannot predict what numbers are going to print it. Now if you remember, just remember these things. Now let's execute the program again. Now if you see,
Random.
the numbers are totally different. And now if we execute the program again, the numbers are again totally different. So that way, we can actually generate random numbers using this random utility. So this is a utility like a helper class provided by Java by default, so that we can actually generate random numbers. So now because we have printed this, we don't need to have print them again, right? So we can remove this. The same can be applied for the initialization part also. Okay. So now how do we do that? Because I is 0 is the, sorry, 0 1 2 3. Okay, we have forgot to put 2 here, but anyways that doesn't matter. So because this itself is a variable, we can again put int I equals to 0 while I is less than or equals to 9, array of I equals to r dot next int. Okay, so now we don't have to have this line of code also, these 10 lines of code. So now if you see, the program has become so small. So when we are using loops, that's the advantage. If we want to repeatedly execute a specific piece of code, we don't have to copy paste that same code. We can use loops. So anyone who is well versed with programming, they will be able to understand this very quickly. But now I have executed the program. Now what is happening? Why the program is not exiting? Can anyone guess? The program, if you, as long as there is red here, that means the program is executing.
We haven't incremented I, right? Yes.
Yes, so that means it will be repeatedly trying to put in the
I
same
repeat.
value. You understood the concept, right, Mani?
Yeah, yeah,
Because we are not incrementing I will always be 0, so this condition will always be true. So as long as we don't stop the program, it completely executes. That is called as infinite loop. So to remedy that problem, we have to use like this. This will actually ensure that once this is done, this gets executed. So now if we execute the program, now we got these numbers. Now if we execute another time, we got some other numbers. So this is how we can actually use while loops. Okay, so not only if we want to put it in array, there can be many cases. Say for example, we want to find out something called as 5 factorial, okay, n factorial. Let's say, let's ask user to give a number, and we will try to find out the factorial of it. Okay, what is a factorial? If we say 6 factorial, it means 6 into 5 into 4 into 3 into 2 into 1. So when we multiply all these numbers until that number to 1, we will be getting the factorial of a number. So now let's write that program. So this reads the number into n, and then let's close scanner. We don't need scanner anymore. And then now what we have to do, we have to create a number to store factorial, and let's put it as 1. Okay, so far we have not found out any factorials. Now let's while, so now we also have to have a counter variable that so the names are not constant. You can use any names. I'm just putting counter so that it will be more clear. If we say counter equals to 1, in fact we can say 2, while counter is less than or equals to n, factorial equals to, so what do we have to do? We have to multiply first this 1 with 2, and then the result we have to multiply it with 3, and then the result we have to multiply it with 4. So what we can do is we can multiply the factorial with factorial itself with a counter, whatever is the number that is currently there, and then we increment the counter by 1. Okay, so now what we are doing is, first there is 1, so when we this loop gets executed, there is 1 here, so 1 into 2, and then this becomes 3, factorial becomes 2. So when this loop gets executed again, we are saying factorial equals to factorial into counter. That means counter is 3, factorial already value is 2. So the ultimately the expression becomes something like 1 into 2 into 3 into 4 into 5 up to n. So that is how it becomes. So now finally when the loop exits, the value inside the factorial will be the actual factorial value. So it's out. So now if we execute the program, it waits for us to enter a number, let us say 7, and the response is 5040. Okay, so this is how we can actually calculate. Okay, so the response 5040 is nothing but 5 into 6 into oh, sorry, 7 into 6 into 5 into
7.
3 into 2. Okay, so this is how we can write the while loop. Okay, so in the while loop, if you remember, there are three parts. One is initialization part, and then condition part, and then the increment part. That this is also, this is very important. What happened when we missed this part? The loop got stuck, the execution got stuck. It's not necessary that there has to be some counter like this. There can be many cases, like say for example, you may be writing a program that executes from now until 7 o'clock. So there is no counter at all. There is no counter that you are incrementing here. What you will do in the condition, what you will check is whether the time is 7 o'clock or not. Okay, so imagine any kind of condition we can put. It's not necessary that we have to put this increment or decrement, but depending upon the cases, you may be able to skip those things. Okay, so Mani and Srinivas, you guys understood?
Yeah, and
Okay, so now as you have understood this loop, the next set of loops will become pretty easy. So the only difference between do while and while loop is the while and the expression will come after the loop body, whereas in the while, that while and expression will be coming before the loop body, which means the condition will be tested after executing this loop body for once. So when this executes once, and then it condition will be tested. If this condition is true, it executes the loop body again. So it's like testing after it has executed. So it will be useful in cases where we want to execute a specific game for once, and then when the user has played the game, we don't want we want to ask whether the user want to continue or not. If the user wants to continue, we will execute it again. Otherwise, we will skip it. So imagine your ATM. In the ATM, when you come in for the first time, it doesn't ask you, do you want to continue or not, right? It simply asks you for the PIN and executes. And then when you finish the transaction, then it says, do you want to continue? If you say yes, it repeats that same process again. Otherwise, it will simply be exiting if you say no. So do while is just that. So first time no condition is tested. Once the loop body executed for once, that is when the condition starts getting tested. Okay, so now let's see. So far we are writing programs in such a way that they will be executed once. What if we want to write this factorial? So now we have this program. Okay, let's not even bother to do while factorial. Let's first do let's write a program in such a way that it asks user to enter a specific number, and then it checks if it is an even number or odd number. Okay, so now if it is even number, it prints even. If it is odd number, it prints odd. It's a simple of program. But what we want to do is we don't want to exit out of the program as soon as the execution is complete. As soon as execution is complete, we want to ask the user if he wants to continue. If he wants to continue, then we will repeat that same process, like asking the user to give the number again. Okay, if he says no, then we will skip. So now let's write that program. So now what did we do? First we have to create scanner. Now if number plus, why I'm not closing scanner row? Because we have to repeatedly do it. So now we should not close the scanner in that case. So number percentage equals number modulo 2 equals to 0. Let's print it even, else odd. So now if we execute the program, this gets executed only once. Now what you want to do is you want to execute that same program multiple times. Okay, so it is waiting for us to enter a number. So I'm managing 7 print sort. Okay, now we want to execute this program multiple times. So how do we do that? We use while, and what is the condition that we give? Until the user gives a n or not. Okay. So now what shall we do is, let's create a variable called string c confirmation. First, initially we have to put the value as yes. Then what we can do is we can put that same condition over here. Confirmation dot starts with,
Buddha, we are trying to do while right here.
yes. I am just trying to show why we need do while by doing else using while first. Srinivas, are you there?
Yeah, Buddha. Yeah.
Okay.
Yeah, got it.
Yeah. So now what we did is we have kept some value in confirmation and say for initially, because while loop test the condition first, this has to be true again. So what we are doing is we are putting yes ourselves. Now we'll ask the user, do you want to continue? So we will give him options yes or no. So what this statement does is it checks whether the confirmation is starting with the character y or not. If it is, it will return true, otherwise it will return false. Now what we have to do, we have to read confirmation equals to scanner dot next line. We also have to do as next. Why I'll tell later. Confirmation and then scanner dot next line. So what this does is this asks whether this prints whether the user wants to continue or not, and then when he types yes and presses enter, it simply puts that value in confirmation, and then while loop starts getting executed. So now when we try to execute the program, what happens is now it prints 67 and then it printed odd, and then what's happening? Okay, do you want to? Okay, let's do. I think we don't need this. Now let's say we are printing 45, and then it printed odd, and then it is asking us whether we want to continue or not. If we say yes, okay. So now I see what is going on. scanner dot next. Art. Yeah, we have to be actually using dot next here. Otherwise, what's happening is when we are the whatever we are enter we are pressing when we are typing the number, that number is being considered as the next line, and that is going into the confirmation because next line character doesn't have y, it is simply exiting the loop. So when we use next here, what happens is it will be waiting for us to enter that again instead of reading from the previous inputs reminder. So now what we did here over here, so now when we press enter it will be executing. But don't you see we are doing some small redundant thing. First we are setting this value to yes, and then we are testing whether this is starting with y or not. But isn't it redundant little? So for the first time we don't really want to ask the user whether he wants to continue or not. We want to execute that, and then for this for once irrespective of whether user wanted or not, and then we check the condition. So for that, what we do is we use something called as do while. So do while syntax will be something like this. Do. In that case, we don't even have to put any value in this confirmation. So now what this program does is it simply executes this without verifying whether the user wants to execute or not, and then it asks whether the user wants to execute or not, then reads what's the user input, and then checks the condition. If the condition is true, this part will be executed again. The do part will be executed again. If the condition is false, it simply exits the program. So now, if you see the program, the actual loop body didn't change at all, but only when we are doing that condition check is what is changing. So now when we say yes, it will be again waiting for us to give a number, and then when we say yes, waiting for number, yes, number, so 9, and so now when we said do we want to continue yes or no, we have entered n, sorry 9. So which is not starting with y. So obviously this will be exiting. Okay. So this is how a do while works. So you guys understood, right? Why we need do while, etc. Okay. So now let's go ahead and read another loop called as use study another loop called as for loop. So for loop, he works exactly like while loop, except that if you see the syntax of the for loop, we have three different sections that are very important. One is initialization, where we are beginning, condition till where we have to go, and then update, how we have to go to the from initialization to that case where the condition becomes false. So this is how we will be able to actually we will be writing the while loop. But for loop, imagine the while loop body takes around 100 lines. So now the user to see which code is actually incrementing or decrementing, he has to go all that 100 lines, and then he has to verify whether that what actually is happening. So it is for the readability purpose, not for execution. While reading the program for the user, it will be difficult for him to understand what is initialization. May have been done around 100 lines before the while loop. So all three can be existing in three different locations. So what for does is for provides a simple syntax wherein we can provide the initialization, condition, and update. What is initialization? We set int I equals to 0, right? That is the initialization part. And condition is I less than or equal to 9 is the condition. Update is I plus plus. I plus plus is the very important, that will be taking us closer from initialization to the case where we can say the condition is false. The loop body doesn't change at all. So now the initialization, this is the while loop syntax, and very the variation is that we give initialization, condition, and update in all in three in the same line, separating with a semicolon. So that is how we can actually write a for loop. Okay. So now let's just write this program. whatever factorial program we have written, let's try it using for loop. So now, as I said, uh, the initialization, condition, and update, all three goes into the same line. So what happens, this while becomes for, and this comes to here, and this comes here. So this is the syntax of while loop. Okay, we don't have to put a semicolon in the after this increment. We have to separate these three sections by using a semicolon. So now what happened is, the for loop will be starting with a starting value of counter is equal to 2, and then it will be continuing until counter is less than or equal to 10, and then it will be incrementing one by one after each execution of this body loop. So the initialization part gets executed once, and then condition part will be tested, then loop body will be executed, then update part will be executed, and then condition update body. I'm sorry, update condition body, update condition body. So this is how the entire looping process goes on in the for loop. Okay, so very small difference. Now if you want to create more variables, we can create by using commas. Well, of course, we may or may not use these access variables in this, but that's the thing. So what is important for you to understand is, uh, this is not important for you to have. Okay, you don't have to have any of these things. Maybe you have those things outside already, so we don't want to put the values again, so you can skip those statements. So if you see now, this is not error, but semicolons are important. Semicolons are the ones that will tell that, okay, there is no initialization statement or there is no update statement. We can very well have written counter plus plus here also. Okay, so we don't really have to bother about writing. In fact, we don't have to write this condition also, but at least we have to put the semicolons. Okay, but it will never come out of the loop. That's why I think it is creating error. So now what we can do is, if we put, okay, I'll come to that after I explained you this subsequent things. So next topics that we have to study when we are actually studying loops are break and continue. You already saw break. What break does? Break allows you to come out of switch case once it executed the required part. So even in loops, it does the same thing. So one way to exit out of the loop is making sure that condition becomes false, right? The another way to exit out of the loop is to actually use a break statement. Okay. So once as how do you use break? I'll show that once I finish this slide. And then continue. Continue helps us actually skip a specific iteration. Okay. So how do we do that? We will see that also. So now we are incrementing counter, and then if we say if counter is double equals to, or counter is greater than n, we don't want to execute this anymore, so we can use break. So what happens is, this will be tested, and then it will be exiting the loop when we actually meet this condition. Yeah. So because we have not given the condition here, we have given it here, but it's not necessary that you give it here only. But in some programmings, in some problems, you may be having to need to have an extra condition check, after which you have to come out of the loop. So in those cases, you will be simply using the break statement. So let's use the for what we have. Okay. So now either we can, sorry, if what happens in this loop, when we execute this loop, this actually comes out of the loop, so we have to check the counter is less than or equal to n. So here we are trying to see whether we can break or not. Okay, so that's why we have given a negative condition, but in other conditions we have to give a positive condition. The condition that checks if we are less than n or not. So now what continue does is, let's imagine this problem in the factorial problem only. Say we want to skip any odd number. So how can we do that? One way to do that is, if counter percentage 2 is double equals to 0, then multiply. So what this does is, this will be only multiplying the is two numbers. Imagine that there are multiple conditions like this. So in those cases we can use another way of skipping this. Okay, what happens is, when this is odd number, this becomes false, so this will be skipped. So there is another way of skipping the. So how do we do that? So when this is not equals to 0, we can say continue. Now what happens is, when the number is not equal, is not an even number, that means when the number is odd, when we say continue, this will not be executed. The any lines that are after this continue will not be executed. Whenever we meet this successful condition, we say continue, this will not be executed. So that means the counter will be incremented by automatically, and then the counter will be checked, and then again this condition will be tested. So this way, whenever there is an odd number, continue means this skips this line number 20 and 21, and then it directly goes to the counter plus plus, and then counter less than or equals to n. So this way we can use continue to actually skip some iterations. Let's say we don't want to execute a specific in a case when counter is equals to 7 అయినప్పుడు మనం ఎగ్జిక్యూట్ చేయకూడదు అనుకున్నాం అనుకోండి. So what we can do is, when we say like this, what happens is, when the counter is 7, that will be skipped from this. The continue will make sure that this won't be executed. Instead, it directly goes to this case. Okay, so that is how we can actually use break and continue. Okay, so there is a slightly small variation for each loop actually. So for each loop we can also say we initially we have used array, right? We have for arrays we have used a while loop. Okay, but for arrays, if we use the for loop, the syntax will become slightly simpler. Okay, so that syntax is called as for each loop. So now here we know that array has 10 elements. Okay, so what we are doing, we are starting from 0 and then going until 9. So in another way, by using the for each loop syntax, what we can do is, we can actually simplify this program a bit. So let's open for each.java, and now for each works something like this: for int. Okay, it doesn't really work that way for int. Let's use integer over here. Okay, so here what we are actually okay, let's do this. We can do it. Let's say we are reading this variable like this, right? Now let's say to print this, we are navigating, we are traversing. This is called as traversing an array. So while we are, what we are doing is, we are traversing an array over here, and to traverse an array, what we are doing, we are incrementing j, and then we are visiting each element. So in those cases, what we can do is, we can use a syntax called as for each, where, say for example, int element, the value element, the name element is not constant, I just gave that name variable, and then we can give array name. So now what this is doing is, because Java knows that this is an array, so what, when we use a syntax like this is called as for each syntax, which itself is self-explanatory. For each element of array, or for each n of array, do this operation. So what this does, it starts at array of 0, puts that value in n, and then it executes this, and then starts at array of 1, puts that value in n, it executes this. So what happens, we will be visiting each element. So now see, when we have to execute the same code for every element of an array, we can simply simplify that code by using for each. We don't have to have this. Okay. So now if we execute this program, we'll be seeing the same result, no change at all. Okay, so you understood for each, right? When we say for each, it means we have to give an array, and then we have to create a variable, and we have to give a column. So then for every loop iteration, it puts an array element inside this variable. So that is how the for each works. Okay. So this we don't have to put any increment. Java automatically takes care of putting them. Okay, so that ends the portion of the for each loops, for each and for loops. Okay, also it brings us to a conclusion of the if else sorry, control statements. Okay, so what I want you to do is I want you to solve these exercises actually. Okay, there are many exercises in fact. So you may take more than one day, especially because this is you may be having some other works. So try to solve as many as possible. Especially don't as you have already solved this one, come to actually loops part. Okay, this PDF I think I've already shared with you guys. Otherwise, I'll share this with you momentarily, and then you can actually try to perform all these exercises. Okay, doing these exercises is very important because understanding loops is one of the more critical and toughest part for anyone who is beginning. Srinivas, as you may be aware of loops already, it may be slightly easy for you. Also, but still try to solve as many problems as you can. Okay, so there are around
Sure,
five
Buddha.
problems
Please share
in.
this.
Yes, Srinivas, you're telling something.
I'm saying that please share this document because this document was not shared.
Yeah, sure. I'll share this. Remember sharing this control statements part. If not, let me just do that now itself. So this has the all the syntaxes that you need to actually syntax examples, etc. Also, it has. So yeah, this has the PDF, and I'll be sending it along with the video recording that once I upload in the YouTube. Okay. So there are other topics. We still have time, but I don't want to cover a new topic now because files need some time for you to understand. Okay, let me send the PDF. So if you want to do it now, you can do. So I just sent you the PDF link, so you should be able to download it. So go through it, take your own time, and try to understand what are loops and all, and then try to uh, try to solve the problems. Okay, so it is very important for you to actually solve all the problems that we have. If you have around five problems, try to solve all of them. Okay, and you can take help of internet, but don't try to copy paste the entire code. Try to understand the logic, use the internet to understand the logic, and then it will be easy for you guys going forward. Okay, so do you guys have any questions on this or even the ones that we have covered so far?
No, Buddha.
Okay. Wonderful. So I'll just upload the video. If you have any doubts, just go through that again. Uh, so let's meet tomorrow morning. Uh,
Buddha, can you please share that? book details you mentioned in.
Which one? Book, yes, I will share that book also. Okay. Okay. Okay, Mani. Bye.
Okay.
Okay, Srinivas. Bye.
Okay.
Okay, thank you. Bye.